Hello, everyone. This is Belinda Carr, and you're listening to my podcast on building products and technology. As we know, the construction industry is ripe for automation and disruption. It has been reliant on manual labor and outdated tech for far too long, which has led to lagging productivity. Every week, I chat with a company that is exploring ways to tackle these issues. Today, I'm speaking with Philippe Block, professor at ETH Zurich. Thanks for joining us, Philippe.
Thanks for the invitation. Excited to be here.
Yeah, I'm really excited too. I was actually hoping to meet you during my trip to Switzerland back in August, but the timing and the dates just didn't work out. But I actually did visit your university, ETH Zurich. I walked into the main building, and it's one of those universities that you hear so much about. If you're in the architecture field and industrial design field, you hear about all this cutting edge technology and research that you're doing. It's something that's like too good to be true, almost. So how did you get into this role? I'm sure people have asked you this question a dozen times.
I must say, yes, the place is a bit too good to be true, and I'm very fortunate to be in such a creative and stimulating environment, supportive environment as well. So how did I end up there? I never really applied for anything. I mean, except for this job. This is the only one that I applied for. I always met the right people. I rolled into one opportunity to the next. And how this one came about is that I was at MIT finishing my PhD with John Oxford.
And that was a PhD in structures, right? Structural design.
More specifically, I developed new methods to assess the safety of historic structures in unreinforced masonry. So why do the beautiful vaulted cathedrals still stand after 500 years? So that's actually a field where there was a need for better tools that actually can explain how safe they are, how long they stand, why they stand all together. And so I was finishing my PhD. I already was excited to finally go to practice and do some real stuff. I had even a job lined up for in Boston. And then my advisor sent me this call for MIT. He got it in his mailbox and for ETH, and it really felt like they were describing me. And so I said, well, that's interesting. Maybe I should try. So I submitted, and I guess I came over as this exotic bird from a totally different background, and so they kind of selected me, and so I started a tenure track position now more than 13 and a half years ago at ETH. So I started here at 2009, and I stepped through all the different ranks, and now I've been full professor since 2017. So for me, the only reason to convince me to not go to industry and to make things happen was that I never visited ETH before, never visited even Switzerland before. But they told me that ETH is the MIT of Europe. And I had such a great experience at MIT that I said, well, that sounds like the place for me. And that's how I ended up here. Yeah.
That's an incredible story. So you said you're not originally from Switzerland. Where are you from?
I'm from Brussels, Belgium. That's also where I started my studies. In fact, I look back at those and I'm super, super thankful because in Belgium for the last 25, even 30 years, there has been a degree that is really in between architecture and engineering. So structural engineering, building physics engineering, so all the engineering aspects of architecture. And I'm so thankful that I started my career like that because it really laid that very broad base for me to be able to always jump back and forth.
Yes.
Yeah. From more design and the sensitivities that have to do with that, and all the way to the very technical aspects of structural engineering or computation and so on. So I'm very fortunate that I could start there.
It's so interesting how things fall into place like that, right? Because this intersection between architecture and engineering seems to be the perfect fit for you. And you have an architecture background, your bachelor's, and then you got your master's and your PhD in engineering. And then this job came along at ETH Zurich, and it seems to have been such a fruitful collaboration. Like, you have done amazing things with the university over the last 13 years. And it's just wonderful that all that just fell into place for you.
Well, thanks for noticing that. Falling into place, yes, to a certain extent, but also
it's also a lot of hard work.
There is, but there's many people that hard work. So it is always a combination of opportunities that are given. I've had the best mentors. That is also very important. People that actually support you throughout your career. And so I hope I can pass this on to others later on, because that has helped me quite a bit. But I mean, because you started by ETH seems to be bigger than life, too much, perfect world, and so on. That's also, of course, an important aspect, that ETH as a university is very supportive. Not only gives you a good framework to work in, but also really emphasizes that they want you to make a difference and to have impact. And they don't fall back on the typical kind of currency in academia typically is how many papers you write. And so they really clarified from the beginning, for us, it's not about that. It's really about you doing something meaningful. So it's quality over quantity. It's knowledge and technology transfer, which is typically not that well recognized in academia, over again fundamental papers and so on. So I try to do both, of course, but I am very thankful to be in such an environment that really pushes us to innovate. So, and that is maybe a difference that I noticed compared to I'm crazy thankful of my education in the US, because that's where the topics that I care about, that's where I learned them. That's where most of my skills, I learned how to present in the US, how to kind of also be entrepreneurial. So all of this I have from this crazy spirit at MIT. But where I'm lucky here at ETH, or what I notice as a difference, is that we maybe have less flashy kind of statements and scoops in the press, but we try to make things happen. So we try to go all the way and to really do the significantly less sexy 15% to actually to make something happen, and not just
talk about it, raise money,
yes,
and
exactly.
claim.
I'm not saying that MIT just does that, but
Absolutely,
I'm just saying that
it's a cultural difference. Yeah.
Well, but also ETH is really proud and supports that and acknowledges that, because you cannot do both. You cannot have high impact journal papers that always seek for novelty, and at the same time have the same energy, time, and effort to make things happen. So I do see some differences. Absolutely. So there as well, I am fortunate that I have maybe the best mixes of both: a very good base education in Europe, an entrepreneurial and open-minded kind of follow-up education in the US, and then now here I can make things happen and change the world. Yes.
So let's dive into the details of how you work. What sort of, whenever you come up with these research topics and something that you're really passionate about, how do you follow through? Is there a collaboration with other companies in Switzerland and in Europe? Is it a collaboration with students, fellow professors? How does that research process work?
Okay, we are maybe a bit of an outbird, and I want to also maybe emphasize that I have done everything together with my best friend and right-hand man, Tom van Mele. We have been developing this agenda. No one knows Tom because he's always in the background working and making everything happen, and I'm the face talking about what we do and coming up with crazy ideas that he then needs to realize. I mean, I'm exaggerating a little.
Yeah, yes. But before you continue, you're talking about your partner in Block Research Group, BRG?
That's correct, yes.
Okay.
We co-lead the Block Research Group at ETH, that is at the Institute of Technology and Architecture. But we are now also setting up companies to be able to transfer. So I can talk about this a bit later, but you asked me about how these things come about. Well, I must say that I got this message already from John Oxendorf in 2005 that about sustainability and these targets and so on. But honestly, if many of us are honest to ourselves, that was not resonating sufficiently back then. But the more you actually are aware of the gigantic impact, negative impact of our industry on climate, on resources, on diversity of species and so on, yeah, that cannot be unseen. So
Yeah.
I must say that this drives everything, and it's becoming increasingly challenging and difficult for our new PhD students, because we ask all of them to be fully aware what exactly are they contributing. Are they clearly contributing, and are they contributing to our biggest challenge that we will face as a society, and that is how to address this real climate emergency, right? And so then you said about collaboration. Yeah, that's an interesting one. I believe in long-term partnerships. So because one of the things that we're trying to demonstrate, you talked about automation and things like that. Part of this is also to really rethink how things are done, and to not just have all these sequential kind of steps, like an architect sketches something fantastic, then an engineer tries not to kill anyone, and then a builder tries to build it as cheaply as possible. So we need to break through that.
That's an excellent summary of the construction
yes,
industry.
That's right. But part of moving along the bucket and responsibility, and also splitting your fees and so on, also means that there is so many inefficiencies that come in. So we are really trying to do that differently. And so these long-term partnerships actually typically are with builders directly, with contractors, because we want to have a full integrated kind of pipeline. And part of that is then also, of course, to be directly connected and have the builder and the fabricator in the story, in the design, in the development from the beginning.
So it's not just a research paper. It's not theoretical. You actually go a step further and make it happen and test it out.
I think we have to. I mean, of course, one should never undersell the importance of fundamental research in general. But for our field, or the fields of architecture, structural engineering, building physics, everything applied to construction and the built environment, there is such an urgency that the proof is really in the pudding and eating it. And so it's not sufficient to just sketch out kind of potentials. It's all cute, and that was fine. We just are nearing the end of maybe a decade and a half of pavilion architecture or pavilion research. That was super important. That was super important to develop the tools to kind of really challenge also how things are coming together. But now we need to make things happen. And so that means that indeed we have to team up with industry to accelerate, to accelerate transfer.
So I'm curious about this. So let's talk about one hypothetical situation. You work with one PhD student on, say, shape optimization of concrete foundations. I'm just throwing a topic out there.
Yeah.
And then you work with a concrete company or some sort of fabricator to cast these forms in place. What happens after that student has graduated? How do you continue that research? Do you kind of advise the next incoming batch of students on, hey, these are possible topics. Does this pique your interest? Would you like to pick up this other student's research from where he or she stopped?
Again, this is we maybe I mean, people that know our work are or have listened to any of my talks feel that there is a crazy red line through everything that we do, and that of course doesn't just come by habit. So there's different ways to do PhDs and also to advise PhD students, but we believe in providing frameworks, a framing that still allows a PhD student to define his or her specific contribution within that framing, but nonetheless to be aligned with previous work. And the reason for that is that it's so much more powerful if you're not having to reinvent the wheel
exactly
every single time when you start a PhD. And in fact, part of this is that 8 years ago, Tom started to develop an in-house computational framework that allowed all the PhD students from day one to start with all the knowledge of the past kind of PhD students. And this in-house framework has now developed into Compass, which is an open source framework for research and collaboration in the AEC. In fact, Tom is right now doing a workshop for McNeil with a Rhino workshop on Compass. And why I mention is that this has been also important to us, is to also in our own organization and for the sake of our own students to try to optimize things. And because again, I mean, there's different, you can scale this up at different levels. How much brain power is being lost all over the world by PhD students having to set up their own environment and figuring out everything from scratch? Why not being able to build upon other people's research? But also in practice, how silly, how sad is it even that offices that are big enough, they develop their own frameworks in-house, they keep it in their bubble and so on.
And then another office, like 100 other offices are doing the exact same thing in these silos. I agree.
Yes.
Yeah.
And so we are really trying to push and to clarify and to lead by example, because we share all our methods open source through Compass so that other people can actually replicate what we have done, how we have approached the problems and so on. So that has been an important aspect in how we developed the group, and also allowed us to go faster, but also allowed us to collaborate faster, because if different PhD students are working on different topics, because all their work is based on Compass, in half an hour's time, literally, they have all their workflows connected and they can start to collaborate. And that is super powerful and super exciting.
That's amazing. So I have to ask you, in your last 13.5 years at ETH Zurich, is there one particular project that really stands out? I'm sure there are several. You've worked on incredible innovations, but is there one that stands out because it was so innovative for the time, but now in 2022, it's become mainstream and you don't even realize how much of an impact it made on our industry? Yeah.
Well, I mean, so you're asking two things, right? So one is, which one do you think has more impact? I have been a bit kind of conscious about this lately, and Tom and I have shifted gears because we want to have impact. And then we have some high level colleagues from practice that then came to me like, you should not be so doubting, like just already your approach to embed structural knowledge and through tools like Rhino Vault fully in your design kind of tools is so important to demonstrate the power of structural geometry, that you can reduce mass, that you can reduce the stresses so that you can activate lower embodied carbon materials and so on and so on. That has probably the biggest impact already, noticeable impact. Also that I can proudly say that the very first free-form tile vaulted kind of structure we did in 2010. And so now you see them everywhere in the world, right? You see them pop up in workshops in India, in Iran. They're big fans of these kind of things. So it's super fascinating to see how all of that spread. But you asked me maybe about that one project that I think is really going to, I mean, if I may say, in a perhaps not that humble way, that we really will be remembered for. I think it is our developments on the floor plates, on the floor slabs. So, and that project is still going on. In the Nest project, we managed to build one floor plate of 5 by 5 meter. With only 3 centimeters, a doubly curved shell of 3 centimeters of unreinforced concrete, low strength concrete. And so that replaces our typical floor plate. But now what is exciting, and it's really crazy, it's happening, is that after a 2-year very intensive research and development phase, we are in the next couple of weeks, literally setting up a company with big industrial giants to commercialize these floor plates at scale. And the reason that I am so excited about these floor plates is that, let me give you an example of potential impact.
Yeah, can you talk about things like material reduction and embodied carbon reduction about this?
No, exactly. So what we have developed, the floor plate is a concrete floor plate, unreinforced concrete that uses 70% less concrete and 90% less reinforcement steel compared to your standard reinforced concrete floor plate. By doing that, we beat any floor system on the market. So you probably think that I'm a salesperson and I'm exaggerating a little bit. But the reason that I can say this matter of fact is because we are in advanced stages of development for a 130-meter tower, so a very large tower in the center of Brussels that was designed entirely around this floor plate. And a second project, a big pilot project, is here in Zug, in Switzerland, and also, again, designed entirely around this floor plate. Why I mention this is because in a research paper, you can always in the beginning say, these are my boundary conditions and so on. But in real life, you cannot leave any stone
unturned. Yeah, because lives are at stake. Yes. There's far more. Yeah,
lives are at stake. That's, of course, that's the minimal requirement we need to hit. But of course, also economical questions, questions of acoustics, questions of thermal mass, and so on. Mm-hmm. And so this is something that we're extremely proud that actually in all these projects, we have not seen any red flags. We are at the same cost, if not cheaper, compared to a typical floor, because the savings are so dramatic, right? But for me, what is also very exciting is that beyond the savings on emissions, beyond the savings on resources, we're actually reintroducing the masonry logic, the reason that cathedrals stand, to discretize our floors so that they have a very natural dry assembly, so that you can take them apart, so that you don't have to lock them in. So you can imagine already an end of life, either easy recycling or you reuse the components and so on. So we are going beyond embodied emissions, and we're really making a fully circular product. And so this is exciting because...
So that's beautiful. So your PhD thesis into cathedral design and restoring old buildings kind of comes into this new, and you couldn't have possibly planned that out during your PhD. You're just pulling all this information in while doing continuing research. That's beautiful.
Thanks, Belinda. But in fact, there were already hints during my PhD of the potential, but it clearly wasn't coming together because I never imagined that and this is a work of almost a decade of persistence, of a lot of investments, of also not giving up, because it's easy to give up or to succumb to the typical kind of academic pressures, and also we live in a world of fast media and social media and so on, and it's of course fun to be able to hit all the news with some fascinating new thoughts. So you can imagine that it needed some persistence, perseverance to stick to this one topic, to stick to compression, to stick to this super boring element, the floor plate. So we stuck to it for for years and years and years, almost 10 years of dedicated research. But that means that now we can go to the market with a product that is indeed, like you say, of course safe, but that is performant, that really uses materials how they want to be used. And what I enjoy today the most is that I get invited to all kinds of events where they think they will be able to pin me down with the typical concrete shaming that is going on today. They say concrete is bad, wood is good. That is an absurd statement, because it's not just about the material.
It's not black and white, no.
How you use the material, in what context, if you consider the end of life, if you consider all the other facets to construction. So I find it very rewarding that indeed the Gothic cathedrals are the key to make the most negative looking material the most sustainable today for the application of floor plates, right? So maybe if you know our work, you know that we like to provoke often. And so we're in the business of shaking our community and making them think beyond their preconceived notions in a way also.
That's incredible. Wow. What a inspirational story for everyone else in the industry. But before we move on, I have to ask you, you mentioned the Nest project, and I've looked this up. It's an incredible collaborative project between, I think, professors at ETH. Could you talk a little bit more about the Nest project?
What a vision by our sister university, EMPA. What they basically did was I believe it was in 2010, they started to build a building with gigantic platforms to receive innovative units. And so basically they thought, let's give researchers literally a platform, physically and theoretically, a framing, a platform that allows them to take more risks than what you would typically be able to do in a real project, right? If there is a small crack happening, you're going to be sued. If there is, of course, structural failure should never happen. But so the thing is that this really allows researchers to plug in and to try something with industry partners that hopefully can be a jumping board to innovation later. And that is exactly what happened with us. So we did this high-low unit with some crazy roof that was built on a flexible formwork. But the key point was these floor plates that I talked about. So we wanted to show this for the first time in a real project. So not in a prototype, because that is also, that for me was an interesting learning, because I mean, if you build a prototype, you can stand on it, you do all the tests and so on, you can do whatever you want. Industry is not interested in it. They need to see it in a real building. So this Nest was a super important milestone, the Nest high-low unit, because that's the first time we built these floor plates. And since then, it has been accelerating. And now we are just a few weeks away from actually setting up a commercial venture to build these floor plates all over the world. Considering
wow,
that
amazing.
we will be, by the way, considering that we will be building more than 200 billion square meters. So that means 2 trillion square feet of floor area throughout the world. And knowing that in a medium high rise, they account for more than 40% of the mass of the entire building, is all lumped in the floor plates, right? So if we can offer such a disruptive innovation, that is going to change the needle, right? That is going to accelerate our path towards net zero indeed. So I mean, you can typically I can speak with images of our projects and so on. So I hope that
I'll
this
definitely
podcast
link.
is,
Yes, absolutely.
hopefully it's not too abstract and what I'm saying, but I'm super passionate. This is such an exciting time to be. Yes. And if maybe this sounds bad, right? Because I'm excited because we can be solving solutions, but on the other hand, it's actually we should be that serious, right? That we have to find solutions, go build better, build faster, like you also said, and so on and so on.
But it's not a bad thing. I mean, we can't just be all doom and gloom all the time. We have to have some positive outlook on this whole thing, and in order to keep us going. Like you pursued this one venture for 10 years because
yes.
There was some positive light at the end of the tunnel. You couldn't have just been like we can't just dive into just the negativity, and yet it's awful, the climate emergency and all that stuff, but we have to look at the positives to
Absolutely.
keep us going.
Because we have to do it together. And actually also something else that I find a little bit a pity is that I witness a lot of black and white reasoning, a lot of kind of lobbying for the sake of positioning yourself. And unfortunately, this is no longer only in industry, but I also witness this a little bit in academia, that people are trying to carve their niche by going to one extreme, while we are all in this together. And we have to not be antagonistic, but we really have to start to also acknowledge that we need many solutions. People that say that we have to work, that we have to build everything in timber, that is the wrong message, for example, because then we would have monocultures throughout the world. We would cut all the green lungs that we have left on this planet and so on. So timber is fantastic in certain regions, but it's not one solution fits all. And that is happening so much nowadays. and I hope that we are not wasting too much precious time on trying to position ourselves with black and white thinking, because we all need to work together. It's really crazy.
I completely agree with you. And it's wonderful that we have people like you, and I'm sure there are other professors and other researchers out there that are shaking up the industry, like you said, being a little controversial and dismissing all these false, or maybe just I'm losing my train of thought now, but incorrect notions about the future of the industry. It's like you said, it's not black and white, it's collaborative. And coming up with this solution for flow plates could be far more beneficial to the industry than someone just advocating for timber and absolutely nothing else. But I'm going to link.
I'm maybe going a little bit too much. I am not a concrete poster boy and a timber anti-boy. No, what I want to say with this is that I witness a little bit too much of a favoring just because of ideological reasons, and we cannot permit ourselves to go in that direction. That's maybe what I wanted to say.
It's going to be very destructive to our entire civilization if we have this like blinders on and we say this is the only solution and we're not going to consider anything else.
That's right. Yeah.
I have one last question for you, Philip. What advice do you have for incoming people in the industry, whether it's architects, engineers, like the next generation of people that are looking for how they can shake up the industry, looking for alternatives to the traditional path down to like becoming a licensed architect or a licensed engineer, something like what you have done? You found the intersection between these two fields. You've carved your own path that is not conventional in the industry.
Yeah. Well, I think I'm rather convinced by the opportunities and the path that I could walk. I do think it's important. It's no longer acceptable to define yourself as an architect only being interested in spaces, in an experience, in maybe materiality, but more on a combination between tactile and aesthetic kind of reasons. I believe that with such a pressure comes such a responsibility. And I mean, globally, being responsible for 40% of the human-made greenhouse gas emissions, 40% of the global waste production in construction demolition waste, 40% of the use of first use raw natural resources. I mean, these are gigantic numbers. And so I find this comes with a responsibility. And so that means that as an architect, you need to be knowledgeable about what matters and what is. So I would advocate to everyone to find that specialty that allows you to make a unique contribution in the right direction of sustainability. So a technical field, most likely, because many of the bigger jumps, the bigger disruptions will have to also have a technical component, like, for example, a structural or new building systems and so on. So I think that is probably a good guess in what direction to go. But for me break with the status quo. I mean, you don't necessarily become an activist, but at least be a proactive changer. And so be curious and as we have been talking about earlier, it does start with education. It does start with actually being knowledgeable enough to go past kind of poster-like statements of that is good and that is bad. Yes. It takes much more. So be curious, be open. I personally think the more you can remain open in your base education, the better. And it's also rewarding, because otherwise, if you see still big architecture offices, I mean, is that the best use of human brain power to have people design 10 iterations and draw up draw up toilet plans and so on on an intern level, and then maybe after many years you get to take the lead on something. And I'm of course exaggerating a little bit, but so give yourself a chance to be more influential. And I think for that you want to complement yourself with some knowledge, technical knowledge. And yeah, so I would say do the same as what I did, and you'll have an exciting life. You'll have an exciting career. Yeah.
Wow. I share a lot of, like, people who have watched my videos and listen to my podcast know that I share a lot of points of view, that we have similar points of view in the construction industry and the architecture industry. But I know that I said that was going to be my last question, but I have to ask you about that poster behind you, because I've been staring at that the entire podcast. What is it?
Yeah, so this is really a not done in Zoom meetings. You're supposed to blur your background so that you don't get distracted and lose your train of thought. No, I thought I like this poster because I'm Belgian, and as a Belgian, one loves French fries. So, and in order to make the French fries, you of course want to peel them. So this is a potato peeler. But this also happens to be one of the most important, one of the most successful innovations from Switzerland. And so in a way, I thought this poster is almost like me. I live and work and I'm very, very happy in Switzerland, but I'm also very proudly from Brussels, Belgium. So that's why I have this poster distracting you in the background, because it's maybe a little bit best of both worlds.
Oh, that's a nice story. Well, thank you so much, Philip, for sharing all that amazing, incredible advice with all of us. I'm going to be, if people want to learn more about the Nest project or other projects that you're working on, what's the best way for them to, like, reach out to you or to look at your past work?
Yeah, I mean, we used to try to keep our website up to date. We're going to revamp it, but that, I would say, that is maybe the first step. But if you happen to be in Zurich, I mean, do reach out. You've seen it yourself. It's worth visiting. There's a lot of nice people around, and so perhaps it's if you are in town, then come and visit us. Indeed, I hope I didn't make a mistake now by announcing this so openly, because we already have a lot of visitors. But no, what I want to say is that we try to be open in everything we do. So on our website, there's quite a bit of information. Do check out the Compass project.
Yes.
If you're curious to discover how we do things, we are trying to there also share our methods and so on. So I would say start there. And then if there's still open-ended questions that you absolutely need to answer, then feel free to contact me and you'll get an answer somehow. Maybe not from me, but from someone on the fantastic team I get to work with.
Thank you. Thank you once again for sharing all that information with us. And looking forward to seeing all the other incredible projects that you and your team come up with.
Thanks, Belinda, and thanks again for this opportunity to share some thoughts.